All right. So today we'll be talking about Leetcode problem 448. Find all numbers disappeared in an array. Given an array nums of n integers where nums sub I is in the range 1 to n inclusively. Return an array for all the numbers in the range 1 to n inclusively that do not appear in nums. So this is very similar to the problem that I did yesterday, where yesterday it was just find the one number that's missing from 0 to n inclusively. So that means the length of the array could end up being what do you call it? The end of the array, the number at the end of the array is actually outside of the list length if every number is there, right? And like the very last number is the one that's missing. But here, regardless of what happens, the length of the array will the length of the array also includes like the last number. So since this length is 8, the number 8 is included. Like the test case could skip out on the 8 and like let's just say for example have a 5 here instead. So but then that would just show that that number is unavailable, like it is not in the problem, like in the array, but like it makes the if condition when checking whether or not we want to swap a lot easier. So like we do normally, we're going to have we're going to have a results is equal to an empty list. Results is basically the same thing as missing numbers, the missing numbers, but you know, just to save time, from instead of typing missing numbers for this right here, we'll just type results, or we could even make it shorter, make it res, right? Same thing, since we're going to iterate through this in a while loop, we need to initialize like our iterator outside of the loop. So I equals 0, while I is less than the length of nums, just to iterate through everything. We're going to have a j equals nums I minus 1. So basically we just want to see, let's see, we are, for example, this one here, since 1 belongs in index 1 because we're in a range of 1 to n now, we need to shift everything over by 1 to the left, right? So 4 would belong in index 3, 1, 2, 3, 4, right? So it would belong in index 3. So basically we're checking if 4 is actually in index 3 with this one right here. Because I equals 0, we get num sub 0, which is 4. 4 minus 1 is 3, right? So we want to see if the numbers are the same there. So if nums I does not equal to nums j. Yeah, so basically nums I, we get 4 here. And then nums 3, because that's where we want it to be. And if this is not in there, we want to swap it, right? So we do the nums I nums j is equal to nums j nums I. And then else, basically if it is there already, we want to increment I by 1. Pretty self-explanatory. And for example, we'll look at this one just to show you the other case where this isn't true. So I equals 0, we get num sub 0, which is 1. And then so num sub 0 is 1, 1 minus 1 is 0. So we know 1 belongs here, right? And so we don't need to swap because 1 is already there. And so we'll go here, I plus equals 1. So now I is equal to 1, right? So now we look at this again. And now that we get here, we see, hey, num sub 1 is also 1. Num sub 1, 1 minus 1 is 0. And we check the thing. We already have the number there. Therefore, we don't need to worry about it, right? So we can still, then again, increment I. And now we're out of the loop here. And so in order to finish off the problem, we need for value in range of length of nums. I'm just going to call it value, but I just don't want to touch I again because I is defined here, and you know, it could make everything kind of wonky. So I'm just going to call it value. For, you know, for num in I'll call it for index, just so it doesn't, I was gonna call it j, but j's are obviously, it's used in here and I don't want to confuse it. So index, for index in range of length of nums, if nums index does not equal to I plus 1, then res dot append I plus 1. Oh, not index. I don't want I. Too used to using I as like the iterator. So nums index, if it's not equal to index plus 1, they want to append it. So basically, like for example here, right? We check the first one, index is equal to 0. Num sub 0 is equal to 0 plus 1 because it's 1. It is equal to that, so we don't need to do anything here. And since it's a for loop, we don't need to increment it, right? Like it'll do it normally. Now we go to here where index equals 1. And where nums sub 1 is equal to 1 as well. But the index is now 1, right? 1 plus 1 is 2, right? So 1 does not equal to 2, so we need to increment it, append index plus 1, which is 1 plus 1, 2. That's how we get that answer. And so this should be correct. Oh, okay. Well, the reason why that didn't work is because we didn't return the solution. Nice one. Yeah, but there you go. So that does work. I just didn't return the solution that we've built. But that's it. Thanks for watching.